Here we're going to talk about inequalities. And so there are four basic symbols for inequalities. So this is less than, this symbol is greater than, this is less than or equal to. Note that it has the line underneath it. And this is greater than or equal to. And so what this means is, obviously the numbers are not equal. One of them is bigger than the other on these top two. And here, in this one, either one of the numbers is less than the other or it's equal to the other. Here, it's greater than or it's equal to. So for example, we would use this symbol in something that says like 4 is less than 8. 9 is greater than 3. 6 is less than or equal to 10, because it is less than, and this is an or, so it's less than or equal to. So, but we can say 7 is greater than or equal to 7, because again, it's either greater than or equal to. So all of these are true statements. This is how you use these symbols. And one way that they generally teach to remember this is if you think of it as an alligator mouth, it wants to eat the bigger number. So the bigger number is always going to be on the side that the alligator his mouth is eating. So when you're using these symbols in algebra, you are going to use them really the same way you would with an equal sign, except in two occasions. So if you don't know how to solve basic algebra equations, you need to watch that video, because I'm not going to go through that here. I'm going to show you, for example, if we're given something like this, 2x plus 3 is greater than 7, and it says solve for x. We're going to treat this just like we would any other normal equation, assuming there's an equal sign there. That's how we're going to go about solving this. And again, there's going to be two exceptions when we can't follow that. So we're going to start out, how do we solve for x? Well, first we want to get rid of that 3. So we're going to subtract 3. Just like on an equals sign, if you do something on one side, you have to do it on the other side. So now we have 2x is greater than 7 minus 3 is 4. How do we get x by itself? We need to get rid of that 2. We divide by 2. If we divide one side by 2, we have to divide the other side by 2. So here, our answer is x is greater than 2. So for this inequality to be true, this x, the numbers that it can take on, if you look at, for example, the number line, it has to be greater than 2. So any number out this way is going to be an answer, not including 2 because it doesn't have the equal sign on it. It has to be greater than 2. So it can be 3, 4, 5, 6, 7, a million, a trillion. All of those will hold true in this inequality. And we can test that. So let's say we pick 3. That's supposed to be right because 3 is greater than 2 and x is greater than 2. So if we choose 3 and plug that in, we would have 2. Instead of x, we're going to put a 3. 2 times 3 plus 3, and that's 2 times 3 is 6 plus 3 is 9, and 9 is greater than 7. So we know that this answer is right. Let's say we picked 0 for x. So again, x is supposed to be greater than 2. So 0 shouldn't work because 0 is not greater than 2. So if we plug 0 in for the x, we have 2 times 0 plus 3. 2 times 0 is 0, 3. Well, 3 is not greater than 7, right? So this isn't right. So again, because x has to be greater than 2, the only values that will work in this inequality are those that are greater than 2. So you can do basic algebra on inequalities. Now let me show you an example of when you have to do something different than what we've done in the past. So we have negative 2x plus 3 is greater than 7. Solve for x. So we start out the same way. 2x plus 3, we're going to get rid of that 3 by subtracting it. So we have negative 2x is greater than 4. Here's where we have to stop and look at this. How do we get rid of this negative 2x? Well, we get rid of it by dividing by negative 2x, just like or negative 2, just like we do in any other algebra. If we divide by negative 2 on one side, we have to divide by negative 2 on the other side. So we end up with x, and here we end up with negative 2. But because we divided by a negative, we have to switch the inequality sign. We have to reverse it. So the answer is x is less than negative 2. So again, if we're looking at the number line, let's say negative 2, negative 3, negative 1, 0, 1, 2, etc. X has to be less than negative 2. So not equal to negative 2, but less than negative 2. So it has to be any number to the left-hand side of negative 2. So negative 3, negative 4, negative 5, negative 1 million. We could put that number in for x, and this would hold true, this inequality. So the key here is, if you're solving for x using an inequality, if you ever divide by a negative number, you have to switch the sign. The same thing is if you multiply by a negative number, you have to switch the sign. If you're just adding or subtracting, like here we subtracted a number, we didn't switch the sign. The minute that we had to divide by a negative, we had to switch it. So if we have, for example, negative 1/2 x plus 3 is greater than 7, solve for x. Negative 1/2 x plus 3 minus 3 is greater than 7 minus 3. Negative 1/2 x is greater than 4. So now, how do we get x by itself? Well, we're dividing by 2, so to get rid of it, we have to multiply by negative 2, because this is a negative 1/2. So if we multiply by negative 2, in order to get rid of that negative 1/2, if we do that on one side, we have to do it on the other side. We have to multiply the other side by negative 2. So those cancel. We're ended up with x on one side, negative 8 on the other side. But we multiplied by a negative number, so we have to switch that sign. So the answer is going to be x is less than negative 8. So negative 9, negative 10, negative 11, all of those numbers will work in this to make that inequality true. So the key is, if you multiply or divide by a negative number, you have to switch the sign.